Here's a problem from the text. This one's kind of directly from the text. If the rate of change of income is R of t equals 40 times 1.002 to the t, that's in dollars per month as measured from some initial time, then what's the change between two different values of t? Now this is not the same as the problem in the book in that I'm going to ask for the change between t equals 6 and t equals 18. So how are we going to get a handle on what the change in income ought to be between t equals 6 and t equals 18 given this rate function? Well, in order to figure out what's going on here, we want to first interpret the graph of R of t versus t. So if this is a graph of R of t versus t, then over an interval delta t, we're going to have a trapezoid here approximating the graph. Now what's the meaning of this trapezoid? Well, the average altitude of the trapezoid is going to be the average value of the rate. So if we multiply the average value of the rate by the delta t, well, that's going to give us the area of the trapezoid, which is going to represent average rate times delta t. Well, the average rate is the rate at which income changes in dollars per month, and delta t is the time in months. If we multiply the number of dollars per month by the time in months, by time interval in months, we're going to get the change of income. So the change of income is going to correspond to the area under this graph, and therefore to an integral of this function. And of course we can think about what the Riemann sums mean and the small trapezoids that we could divide this graph into, and we could confirm our idea here. The other thing, of course, that we could determine from a trapezoid is the slope, but in this case the slope is just the rate at which this rate changes. We're not interested in that. What we're interested in is the integral from t equals 6 to t equals 18 of the rate function. That integral is written as integral from 6 to 18 of 40 times 1.002 to the t dt. We could use derive and put that in using the int function, int of this function, comma t, comma 6, comma 18, to review that for you a little bit. And that's very straightforward. And in a short time, we'll look at how to find derivatives of exponential functions, which will allow us to find antiderivatives of exponential functions, and then we can use the fundamental theorem of calculus to actually calculate the exact value of this integral.